In the last few weeks, we've gone over a lot of different rules for finding the derivatives of complex functions that are made up of simpler functions. We've learned about the power rule, the product rule, the quotient rule, and now the chain rule. One of the things I like to do, it gives me a little comfort when I'm just kind of memorizing a batch of rules and not necessarily looking at the proofs of all of them, is that I like knowing that they tie together, that there's some sort of logic going on between them. And one of the things I want to do in this video to show you is to show you that we can figure out what the quotient rule is just from knowing what the product rule is. It takes knowing the product rule and then a little bit of algebra. This really helped me out at one point in time when I was taking a test. I don't think it was the AP calculus test, but it was another test that required you to know some calculus, and I completely forgot the quotient rule in the middle of it. And I sat down and did something probably pretty close to this during the test to kind of remind me of what the rule is. So this is, the kind of thing. Sometimes you can do math to remind you of something that you forgot to memorize. So we've got the function h of x, which is equal to f of x over g of x, and we want to know what the derivative of h is. Okay, and so we would use the quotient rule for this, but let's say we didn't know the quotient rule. Well, let's do a little trick. Let's multiply both sides of this equation by g of x, and we'll rearrange the sides. So this is just equivalent to saying that f of x is equal to h of x times g of x. So in this first equation, we were taking the quotient of two functions. Now we're taking the product of two functions. And if we know the product rule, we can calculate the derivative of this. So using the product rule, we know that the derivative of f is equal to h of x times the derivative of g. And then we add to that the derivative of h times g. Okay, so the product rule just says you can take those. Calculating the product is just a matter of taking those two things, just taking the derivative of one side, multiplying it by the other, and then adding those two together. Okay, so let's remind ourselves of what we're looking for in this equation. We're trying to figure out what h of x is. And that's cool. H of x, it isn't on the left-hand side of the equation, but it is right here in the equation. So if we can rearrange this equation and solve for h prime of x, then we've got our equation. The other thing we can do is we've got h of x here, and we could remove that and replace it with, we know that h of x is equal to f of x over g of x. So why don't we start off with making that substitution? So f prime of x is equal to, instead of writing h of x g prime of x, I'm going to write f of x times g prime of x over g of x. So I just replaced h of x with f of x over g of x plus h prime x g of x. So I want to solve this equation for h prime of x. And this from here on out is just going to be simple algebra. So first thing I want to do is I want to take this big term and move it on the other side. I'll rearrange the two sides of the equation. So that works out to h prime of x times g of x, what we have on this side of the equation. And over here, we've got f prime of x minus f of x g prime of x over g of x. All right, so we've got two terms on this side of the equation. Why don't we put them under a common denominator? All right, so in order to do that, I want to make the denominator of this term g of x. So I'm going to multiply the numerator and denominator of that by g of x. And so just writing that out with one term under the denominator, we've got f prime of x times g of x minus f of x times g prime of x And this is all under a common denominator of g of x. So that's nice. This looks pretty good. The only problem is I don't have h prime of x alone on this side of the equation. I've got this extra factor of g of x. So I want to finish up the problem by dividing both sides of the equation by g of x, and that gives me h prime of x is equal to f prime of x, g of x, minus f of x, g prime of x. So I've got this g of x that was here before. I'm dividing it by this g of x over here. So that gives me g of x quantity squared. And that is what the quotient rule says. To find the derivative of a quotient, take the derivative of f of the numerator, multiply it by the denominator, subtract the numerator times the derivative of the denominator, and then all of that is over the square of the denominator. So I hope that gives you a little sense of how you can use the product rule. It's another example of using the product rule, and it's a way that you can derive the quotient rule just from knowing the product rule. So calculus is starting to bind together a little bit more closely.